Hello, this is Barry Milliken, and this video will introduce you to my new extension for SketchUp called 2DXY Site Survey Tools. These are tools to draw land or site survey for building projects. I developed my extensions under the brand name of 2DXY because although I love the 3D in SketchUp and I've been using it for 15 years since it was in beta test, I think SketchUp needs some help with certain two-dimensional aspects of design, and surveying is one of those. A survey is, by definition, a two-dimensional drawing. All the distances are, by definition, projected down to the XY plane. I am an architect, and I develop it for my own use. This is the kind of project, an example of the kind of project I do. And anytime I get a new project or even a prospective project, I ask my client for their existing or old survey. They may have to have a new one made for permitting on the new project, but I can't wait for that. If I want to start design, I need a survey because without it I can't tell what the limits, the legal limits on setbacks and allowable site coverage are that are crucial to even the starting day of design. So they usually give me a survey that looks something like this. This is actually one done by computer. A lot of them are older than that and done by hand a long time ago. This is a different project, but it's a fairly simple survey. It has a 120-foot boundary on the south, 100-foot on the left, a short boundary, a straight boundary on the north here on the north corner, then an arc that sets back from the entry roadway, and another one on the east of 125. Surveys, of course, are dimensioned differently than other drawings, as you probably know, with bearings and arc lengths and things of that sort. And I've drawn this survey in SketchUp, and I'm going to show you what it looks like. So I've drawn this in SketchUp using my SiteSurvey Tools. When you do install this extension, you'll have a small toolbar, which I've put down here to avoid cluttering up the existing toolbar, but you can put it wherever you like. It has 4 tools and a help button. The 4 tools are to add a bearing connected to a selected bearing or arc, to add an arc connected to a selected bearing or arc, to edit a selected bearing or arc, or finally to add an area label like this one to the selected polygonal face. So that you see each one of these 4 commands requires the selection of existing graphic element first. So the way you get started with a new survey is to simply draw a regular SketchUp line. I'm going to draw it over here to the right. It doesn't really matter where you draw it, except it does need to be on the XY plane, which is why you'll notice I'm in what SketchUp calls top view here. Recommend you do the same thing. And this line, I'm going to select it and edit it. Here's the blue pencil edit button. And up comes an input box that has actually derived from this arbitrary line a bearing and a length that I've just drawn. I'm going to use the input box to set parameters that make this line comply with the actual surveyor's bearing that you see on the left over here. So it's to the north. The angle is 6 degrees, 30 minutes, 40 seconds to the east for a distance of 100 feet. And there you see that bearing. You see next to it a shorter construction line, a guide that shows you where it was, just as a little feedback on what you're doing. you'll see that this bearing is colored blue. That means it's already been pre-selected for to help you in adding the next bearing or arc. So we need to add a bearing, the short bearing on the north side. So I'm going to add a bearing to the end of the selected bearing. Up comes the same input box. You notice on the left these input boxes show you what the allowable limits are. You can't have a survey bearing larger than 90 degrees. You can't have a length 0 or less. And the software checks if you make these kind of mistakes. It warns you and tells you to correct them. So in this case we have a bearing that's to the south, 83 degrees, 29 minutes, and 20 seconds. It's also to the east and for a distance of only 16.93 feet. We're going to click OK on that, and there's the bearing. Now, we need now to add an arc connected to the end of this bearing. That's this button here, Add Arc to the end of the selected bearing. And when you click on that, up comes an arc input box. Arcs are defined by a radius, in this case 101.98, a direction of curvature from the last bearing or arc. So this bearing, we're curving to the left, not the right. But just for illustration purposes, I'm going to, by mistake, leave it to the right, so you can see how we can correct that kind of mistake. Then the third parameter is a decision about which of three control factors define the arc. These are the three ways that surveyors define arcs, either by the center angle, the arc length, or the chord length. Usually they use the arc length, and in this case the arc length, the symbol they use is L, is 53.13 feet. So I'm going to put that in as the arc length, 53.13. The other two parameters are going to be ignored. And I've put in right, and we'll see what happens. Here's that arc, here's the dimensional notation. It shows you where the center is. And these two guides here, this one and this one, show you the incoming tangent to that arc and the outgoing tangent in case the next element, whether it's a bearing or an arc, is tangent to this arc. Obviously this arc was tangent to that previous bearing. But of course I've seen that I made a mistake and I should have curved to the left instead of the right. So this arc is still blue, it's still selected. I can click on the Edit button. Up comes the same input box. I'm going to leave everything alone except for the direction from right to left. And now I've corrected that arc. And if we move the screen a little bit, you'll see the center is way up to the north there. There's a new guide showing where the new tangent line would be for the next bearing or arc. And we can proceed to draw this next bearing. So this arc is selected. Just as an illustration, I'll show you what another arc tangent to this would look like. This is, we'll put in a shorter radius, maybe 45 feet, also to the left, and you'll see that arc with its center tangent to the one we've just created before. I'll undo that and go back. I have to select this arc, add an arc, and this case 45 to the right. And you'll see an arc that is curving to the right that's tangent to this one. I put a different length in, but you understand the idea. Now let's go back and do our bearing, add a bearing connected to the end of this arc. In this case, what happens when you connect a bearing to the end of an arc, the bearing information here is defaults to the bearing that the tangent line implies. So if I want a tangent bearing, I can just leave this alone and just change the length. But of course, in this case, I'm making a right turn. The new bearing needs to be south, 18 degrees, 13 minutes, 45 seconds. It's to the east, and it's at 125 feet. And there you see it. So at this point, I'm ready to close the traverse, as they say, and add a bearing across the southern boundary of the site. I could enter these particular bearing parameters, but I want to make sure that I connect these 2 points exactly. And so to do that, I'll just draw again a standard SketchUp line connecting those 2 points. That adds the face defining the area of the parcel. I select this line and edit it. This tells me the actual bearing and distance of this line that I've just drawn. And you'll see that it's not exactly what the surveyor said. It's about 2/1000th of a foot longer than he indicated, and even the seconds of the degree are off by 5 seconds. Now 5 seconds, I mean, you have to remember that a degree is 1/60th, or a minute is 1/60th of a degree, and a second is 1/3600th of a degree. So 5 seconds is about 1/700th of a degree. So these are very small rounding errors, and all surveys have them because surveyors can't be that accurate in the field. So this is well within an acceptable range of error. And this application is only going to show 2 decimal places at most. So by hitting OK, it puts in the indicated dimensional information. And then I can select the face of the plot, click on the area tool, and up comes this input box, which has an optional label that I can put in, lot 102. I can decide to show the area or not. It shows me what the area is going to be here. I can show the perimeter or not. I can decide how many decimal places they'll have, and even I'll show, in this case, the acreage. So there you have the finished drawing of this lot survey. But now I need to illustrate what happens if, in the case, this final closing bearing is significantly off. If it's significantly off, so either you have a very bad survey or you've misread it or made some typing error. And let's say, for example, that when I entered this first bearing, I made a typographical error. And I've now looked at my survey and I realize that must be the cause of this problem. So what I can do is take the eraser tool and delete this closing bearing because it's wrong and this is wrong. So let's go back and edit this bearing and correct it. So let's say, for example, that perhaps I misread the survey and it should have been a length of 80 feet. And the number of degrees should have been 16 instead of 6. Here you see the updated version of that bearing. And this dotted construction line shows you where it was. So what I need now is to move these elements to connect to that new location of that bearing. So if I select the first one and right-click, select all connected, that selects this entire string of elements, the first bearing, the arc, the second bearing, and all of their dimensions. Then I can go and use the regular SketchUp Move tool, select that endpoint, and move it to connect to the new endpoint of my edited bearing. Now I'm in a position to close the traverse again. Select that closed bearing, edit it, accept it, that dimensions it, select the face, put in the parameters here for the area again, and I'm completed my work. Now let's go back. I'm going to do a few undos to take us back to where we were before, because this, of course, really was a correct drawing. And I'm going to just delete all the guides that are no longer needed. And the first thing I need to do, it's very important to, now that the survey is done, I don't want any of my future work to mess with it. So I'm going to first select the polygon and Control C in Windows to copy it to the clipboard, because I'm going to use it in a minute. But all of these elements, I'm going to select them all and put them in a group. That protects them from any changes that I might inadvertently make in the rest of my work. This is now cast in stone. It's not going to change for the rest of the project. So I put it in a group, and I'm going to put it in a separate layer, survey layer. And now I'm going to illustrate what you can do with this information for zoning analysis, just using regular SketchUp tools. So I'm going to go to a different view here, 3D view. This is our plot that we've just drawn. This view turns off the dimension. There's a special dimension layer that I add, which I've turned off in this view. I'm going to insert this polygon from the clipboard, the face, Control V, and move it exactly where the survey was. Now I'm going to turn the survey layer off and work on this now polygon that's sitting in isolation by itself. I'm going to select it, pull it up to, let's say, 6 feet. This is going to become my terrain model. And this site happens to be flat, but if it wasn't, I would work on a terrain model as using this as the basis of it. I'd triple click on this and assign a material like grass. Maybe put some dirt. I don't want to put some dirt around the edge. I'll do the other sides later, but I'm going to select all of this, make it a group, and put it in my terrain layer. Whoops, put it in the wrong layer. Undo that. Okay, so now I'm going to Control V, insert my polygon again, put it exactly where it was. Turn off the terrain layer, and this is in the terrain layer. Now I'm going to use this polygon the third time for my zoning envelope. So in this case, I'm going to change the color of it so we can see what we're doing. I've looked up the regulations, and using the standard tape measure tool, I'm going to create setback lines. There's a 10-foot setback from each of the side yards. I'm typing into the control box in the lower left 10 feet. Another 10 feet here. There's a 25-foot legal setback from the rear. And from the front, there's also a 25-foot setback. But since we have both a edge and a arc, I have to select those and use the offset tool to come back 25 feet. Now I can, using the line draw tool, find that intersection point and connect it to these other intersection points. To create the space on the lot where I can actually build something. So now I can delete all the other information I don't need. I'm going to select this new face, pull it up by the 30 feet that's the allowable height for buildings on in this district. I'm going to triple click on this and apply a transparent color. That's my true three-dimensional zoning envelope. I'm going to make a group out of it and put it in the zoning layer. Now, I've already done this, of course, on this project, and so by showing you here what this house looks like with its zoning envelope, you can see I've actually changed the envelope to illustrate this design, which is a second-story addition on the back of the house, where the roof is now penetrating illegally the zoning envelope, and even part of the back wall penetrates. And as I'm working, I can easily, to do this design, I can easily turn on and off the zoning layer. Like this, to help me be sure that I'm doing something that's legal. So that's an introduction to this tool, 2DXY Site Survey. I'm going to be doing a more advanced topic video on the same extension, which you should look out for. But if you're an architect like me doing this kind of work, I'm sure this extension will pay for itself the first time you use it. So thanks for watching and have a nice day.